Good afternoon and namaskar to all of you. We at MNIT, the important part of engineering education ecosystem in the country, know that there are three pillars of our professional life. That is teaching, research and administration. Gone are the days when we had only teaching in our scope of work. Research was just limited to getting PhD for promotion to the post of professor. And as I remember, administration was just limited to hostel warden, control of examination and head of the department. As teaching and administration are not in the agenda today, we will not talk much about all this. But as far as research is concerned, we have witnessed a sea change over last 2 to 3 decades. From almost no research to a situation when we produce hundreds of PhDs and maybe hundreds of research papers in reputed journals, adding new knowledge to the existing. Research is essential for generating new knowledge, but this knowledge may not be useful unless it is converted to innovative products and service processes of value to the society. Here we are here to know about how it can be done, and who will be the better person to tell us about this than Professor Rao, who is a teacher, researcher, administrator, and innovator with 52 PhDs, over 400 research papers, 50 patents, including 20 US patents, and most important, 2 successful startups to his credit. Professor Rao, speaker of the day, Professor Pali, my faculty colleagues, staff, and dear students. A warm welcome to all of you to this lecture on research to innovation, bridging the gap in Indian higher education institution. In today's lecture, Professor Sorana from University of Kansas is also here along with his Gyan course attendees. He is first batch of BITS learner. Welcome, sir. We have had 5 institute lectures by prominent speakers from within and outside country. Professor Ashutosh Sharma, Professor Jean Tirole, Nobel laureate, Professor S.S. Murthy, Professor A.K. Chaturvedi, Professor Rangan Banerjee, on the topics ranging from benchmarking of NITs and IITs, 5G, future of technology, and energy and environment. And today we are part of the 6th lecture by Professor Rao. To start with, I would request Professor Pali, Director MNIT, to please welcome Professor Rao with a floral bouquet.
So first of all, a very good evening. We are very excited to have Professor Rao with us today. And honestly, sir, we never thought that this audience will be of that magnitude. So we all had a doubt, like because of summer vacation. But I'm very sure because of your not only academics, but because of your outreach and some of the global comments that you make on academics for the betterment of this country, probably that has attracted the presence as well as attracted many of our graduates as well as senior faculty colleagues to be part of this event today. Many one of you may not be aware that today I am actually frank that Professor Rao happened to be my mentor. Today I am here because of him. So one bigger round of applause. Without taking much time, the floor is yours. Professor Rao, please welcome.
Before inviting Professor Rao for the lecture, I would like to formally introduce him to you. In fact, I feel elated to introduce him to you. Professor V. Ramgopal Rao is currently the Vice Chancellor of BITS Pinani Group of Institutions. Prior to joining the BITS Pinani Group in 2023, Professor Rao had served as the Director of IIT Delhi for 6 years during 2016 to 21 as a chair professor for nano electronics at both IIT Bombay and IIT Delhi. Professor Rao is an internationally acclaimed nano electronics researcher with over 480 research papers and 50 patents, which include 20 US issued patents. 15 of his patents have been licensed to introduce industries for commercialization. The IP on CMOS SoC applications developed in his group is now used in hundreds of millions of ICs sold all over the world. Professor Rao is a co-founder of the two deep technology startups at IIT Bombay, NanoSniff and Solutions, which have successfully commercially produced products in the market. For his research accomplishment, Dr. Rao has been elected as Fellow of IEEE, a Fellow of the World Academy of Sciences, TWAS, Indian National Academy of Engineering, INAE, the Indian Academy of Sciences, and National Academy of Sciences, and the Indian National Science Academy, INSA. 52 PhD students have been graduated so far under his supervision and are working in leading academic institutions, semiconductor industries all over the world, including India. Professor Rao's research and leadership contributions have been recognized with over 35 awards and honors in the country and abroad. He is a recipient of 3 honorary doctorates. The recognitions Professor Rao received include the Shanti Swarup Bhatnagar Prize in Engineering Sciences, Infosys Prize, IEEE EDS Education Award, and many others. Professor Rao serves on the editorial advisory board of several leading international journals such as ACS Nanoletters, AIP Applied Physics Reviews, IEEE Journal of Flexible Electronics, etc. Dr. Rao has delivered over 200 plenary, keynote, and invited lectures all over the world. Now I invite Professor Rao to deliver his lecture and enlighten us on the table. Professor Rao.
You heard all those technology achievements and everything, and if you could not connect my laptop to the overhead projector, it would have been a challenge. I'm very happy to be here. Very happy to be here. I would like to thank Professor Padi, Professor Mittal, and all of you for inviting me for this event, for giving a talk here. So in fact, I am now in Pilani, Rajasthan. So I am part of the Rajasthani community. So in fact, just to prove my credentials, I can show you, I have now started. Yeah. And in fact, while coming, I was asking Professor Mittal, getting speakers. Maybe one of you can sit here and I say this please. Please come. So in fact, I was asking Professor Mittal, getting speakers is very easy, but can you get the audience? That's always a challenge. And then the first thing he started saying is last day of the academic session and multiple reasons why there might be very less audience. I said these are exactly the reasons I used to give to my visitors in IIT Delhi. So I think it's always a challenge to get the audience, but I think I'm happy to see that some of you are interested in listening to my talk. And so I will essentially talk about the title I have chosen intentionally is Research to Innovation, bridging the gap in Indian higher educational system. So what is research? Of course, we all know, generation of knowledge. But innovation is application of that knowledge. So now that we are all generating a lot of knowledge, how do we apply that for some benefit? And it could be societal benefit or it could be anything. So at the end of the day, generating value for research is what is innovation. That is the definition for innovation, which I will be using as part of my talk here. And if you look at innovation, one of the ways you also judge is the product-based companies. We have developed certain technologies, developed certain products, and they have been commercialized now. People are buying those things. So startups is also one good metric for innovation. So India has about 107 unicorns now. These are all the unicorns in India. I mean, that number is growing. Almost every month you generate some new unicorn. And one thing which is important to also note is there is none in this which is a deep tech or product based. All of these, if you look at, are essentially e-commerce unicorns. These are all fintech kind of ones, but there is no hardcore technology anywhere in these unicorns. So the question that therefore we are asking is how do we generate unicorns out of products, out of research, out of what comes out of deep technologies being carried out in institutions such as MNITs and IITs and all of that. And so this is the question that we need to ask ourselves. And so these are also mostly the business model kind of innovation, which is what you see. I think to have a deep technology kind of a unicorn, I always say that the academic institutions need to play a major role. And the research happens in these institutions. And unless these institutions start to convert their knowledge into wealth, right? The unicorns will not come, the products will not come out of this process. So that's where the academic institutions therefore need to play a major role if we want to change this scenario for the country. Now, when you look at academic institutions, there are three aspects to any academic institution. These are the three things that we are supposed to be doing as a faculty and overall as an institution. Education is one of them. Of course, that's the main reason why we are here. I always say that we are here because students are there. Otherwise, all these institutions do not have any sense, do not make any sense. Therefore, there is education, of course, which is imparting the knowledge that has already been generated. Research is about generating new knowledge, as we all know. Therefore, education and research need to go hand in hand. So you are disseminating whatever knowledge that is available. You are also generating new knowledge. So therefore, over a period of time, let's say 5 years, 10 years, whatever is there in the research papers will get into textbooks. That's the reason why textbooks are continuously rewritten and there are new editions for textbooks and all of that. And the last aspect is the innovation. So this is again the place where you want to translate that knowledge into wealth. So that is the process which is innovation. And I would always say that while education and research we are doing very well. I think if you look at MNIT alumni or IIT alumni, they are the reason why these institutions are so well known. So on the education front, we are doing very well. On the research front, as I will show you, India is again doing very well. But on the innovation front, we seem to be pretty weak. In fact, there's hardly anything that's happening, in the deep technology space. Even if you look at the best science that has ever been done in this country, the Raman effect, the C.V. Raman's effect, almost every Raman instrument in the country is imported. There is not a single company in the country which is manufacturing and selling any of these Raman instruments. So even such a great science we could not commercialize. I mean, we tend to be falling behind when it comes to the knowledge to wealth translation. So that is what is the kind of the point. India is a large country when it comes to education. Over 1,000 universities and over 38 million students studying in our academic institutions. And there are, these are slightly dated. This is 2019 data, I guess. So therefore, looking at the growth that's happening, now we have something like 300,000 PhD students in all our academic institutions. And they're all doing research, we're all publishing papers, and a lot is happening on that front. And India currently ranks third in the world when it comes to research. When you count the papers that are being published in good journals, these are not even, I'm not even counting those journals which are like predatory and all that. Even by the good journal standards, we seem to be ranked third in the world, and we are ranked third behind China and US. Every fifth paper comes out of China. Every fifth paper comes out of China. Every sixth paper comes out of US. But every 20th paper comes out of India. So we are way behind when it comes to US and China. But we are there. I mean, we are at least third in the world when it comes to research. And India is also one of the fastest growing countries in terms of scientific publications as compared to the world average of 4%. At this rate, maybe we might overtake US some point in time. Of course, when Trump was there, I used to say with enough confidence that we might overtake US, but now US is also doing well again. So, but as the US and China, with the considering the gap, I don't think we will ever be able to overtake them with the kind of investments we are making in science and technology, unfortunately. But still, the credit must go to Indian scientists, people like all of us, that we are doing pretty well. We have become experts at converting the money that is given to us into knowledge, into research papers. In fact, per dollar spent, Indians can write more papers than anybody else. So we have beaten China on that metric. Nobody comes anywhere close to India when it comes to, you give us money, we can write as many papers as you want. So that we seem to have mastered that kind of an art right now. But the problem here is, while we have become experts in that conversion of money into knowledge, but we are very poor at converting that knowledge back into money. But that is basically because this is what is missing right now. And I would like to convince you that that's because of the way the research is carried out in our academic institutions. So for us to be able to translate our knowledge into wealth, we need to be able to pick up societal problems and need to make them our projects. I think that needs to happen. The entire thing comes down to how we choose research problems in academia. That is where the problem actually begins. With the way we actually do research, and I will also talk about it in the next few slides. So I just wanted to convince you that we are doing pretty well in terms of research. This I have research from Elsevier. I looked at the data, and then you see that in every area you choose, any the recent and most advanced kind of an area, India is 5th position, 3rd position, all of that. But you might say that we are publishing papers, but is anybody reading them? That's a question that is often asked. But even in terms of citations, right? So this is the recent data. The 1998 to 2000, this particular decade, for example, number of papers, and then we were nowhere. These are highly cited scientific papers, country rankings. We were not even there until the last decade. But this decade, for example, we are at the 7th position. So we have displaced South Korea and Japan, and we are now among the top 10 countries when it comes to writing the highly cited papers. So, we looking at all the negativity around the academia, unfortunately, we seem to think that writing papers is bad or anything. But nothing wrong about it. I think as long as you are able to write good papers, if people are citing them, I think we are doing a great job. And India is indeed, doing pretty well, considering the low amount of investments that go into the science and technology. R&D expenditure as a percentage of GDP, if you look at, India is at the bottom of the table. We are comparing ourselves with South Africa, Pakistan, Philippines. We are in that kind of a club right now. And the countries which are spending maximum money are Israel and South Korea. So these are the countries which are spending highest amounts as a percentage of GDP. Obviously, they are also the leading nations when it comes to innovation and all of that. So therefore, I think this is one aspect which is bad about India, that we are not spending enough money. In fact, as a percentage of GDP, our investments are going down, which is a cause of concern. The economy is growing, so you at least get the same amount of money or slightly more money, but as a percentage of GDP terms, our investments have continuously been falling for higher education, and which all of us have been talking about. And this is not I have invented. I have actually taken this from Niti Aayog. Even Niti Aayog is saying that. I don't know who are they telling that. I thought these are the guys who need to be able to implement something. So everybody is saying it, but nobody is doing anything about it. So that's the current problem with the science and technology investments. But anyway, hopefully, someday there will be more investments, and let's hope for the best. So if you look at the three aspects of higher education, like I said, education, knowledge generation, we are doing very well. Innovation is what is missing right now. But for knowledge to become innovation, R&D to become innovation, I would, I would like to say that, what is missing is the relevance, right? The research that we are doing is not relevant to society. Right? Most of us pick up a problem from library. Now, how do we choose research problems? I mean, including me, when a PhD student comes, what is that we do? Literature review, right? That we tell the student, go to library and do a literature survey. That's what the student starts with. And then does a literature review, comes back and says, sir, this is done, this is done, this is done, but this is not done. Therefore, the student starts doing that, and then you write another paper. And that's how the research basically advances, and which is good. Nothing wrong in that again. But if all of us only do that, right, then nothing will happen. We will only be publishing more and more papers, but the society will not see what is happening in these academic institutions. In fact, I have always argued with MHRD, the Ministry of Education, when I was a director, that the whole model of building our academic institutions needs to change. Today, I was mentor for IIT Jammu. We created IIT Jammu. So while creation of IIT Jammu, how does the whole IIT building process start? You of course get the approval. The place is decided by politicians. We have no say where the IIT will be established. And then you prepare a DPR, right? And then you go to ministry, and then the committees and all those import committees, all of that approval happens. The first project for building of any IIT is the compound wall, right? You are allocated the land, and the first project for building any IIT is the compound wall. So you build a compound wall around that. You put a gate and you put 2 security guards, and after that, what happens inside stays inside. Nothing really, nobody outside will even get to know what is happening in these universities. Now your hostels to labs to everything is inside, and in fact, other day I was in IIT Bombay, I was visiting for some purpose, and the security guard wouldn't get me in. He is asking for a QR code. He said, to enter IIT Bombay, I need a QR code. I said, why do I need a QR code to enter IIT Bombay? So, but then, that's a kind of a security that we have created in all these institutions, and as a result, our connect with the society is completely missing. Look at American university. If you go to any American university, the whole town becomes a university town, right? There are no compound walls, there is nothing like that. The university merges with the city that it is in. It transforms the whole university, the whole town gets transformed into a university town, and that connect with the society is very critical for any institutions to become a center of excellence. And this started in the US way back in the Model Act. In fact, if you look at that on Wikipedia, Model Act, the land grant university model, the entire, all the top universities in the US were all created, starting with MIT to many other universities are land grant universities. These are all universities which promise to work on societal problems. The Model Act of 1857 actually talks about agriculture and mechanic arts, and they said that any university which works on problems of the society will receive all of these kind of things from the governments and the land and everything. And that is how they connected their universities to the society. In the process, they actually became the well-known centers of excellence. And until that time, the US universities were also following the German and UK universities. The Germany, UK were pioneers before US universities took over. And Germany, UK, they were also doing natural sciences, arts, culture, these kind of areas. The US universities were following them. But thanks to that land grant university model, the university connect with the society is the sole reason why the universities in the US came up and then became known for what they are today. That is what that needs to happen in the country. Our universities need to connect more with the society. So that is, as part of research, we can of course do that. And when that happens, when the relevance happens, and then the delivery, you develop a technology, you build a prototype, how does that go to the society? That can go through 2 means right now. These are the 2 ways in which we all know how to translate technology. One is the industry connect. Right? You work with the industry takes your technology and commercializes that, and or uses it in some product, and some way the industry gets benefited, which is good. That's how the society benefits eventually. The other way is startups now. Right? So because there are no industries in the manufacturing space in this country, therefore there is nothing much you can expect. If you develop a technology, it's very difficult for some industry to come, observe the technology, build a manufacturing plant and get it out into the market. So that process, sometimes looks very daunting in a country like India. But what can always happen is the startup kind of a culture. That you start your own company, you have your PhD students as co-founders, and then you take it forward, and if you find the right kind of a PhD student, you can actually commercialize the technology. But again, you need to find the right kind of a PhD student. And at IIT Delhi, when I joined IIT Delhi, I did not know, one thing that was very clear about IIT Delhi was the number of startups from among alumni, right? Almost 32, 34 unicorns coming out of IIT Delhi alumni alone. At that time, every third unicorn in the country came out of IIT Delhi alumni. And I was surprised, what is that IIT Delhi is doing so differently that other IITs are not able to do. I come from IIT Bombay after being 18 years in IIT Bombay. So I was actually puzzled, what is that IIT Delhi has been doing so differently that every alumnus wants to become a co-founder, every alumnus wants to become an entrepreneur, and so many of them are able to create these unicorns kind of thing. And when I did research and talked to people and looked at the data, it was actually very simple. You read the surnames of all these unicorn founders, Bansal, Mittal, Gupta. Other than that, there was nothing IIT Delhi did. Traditionally, IIT Delhi attracted students from the business communities. People, children of business communities. These are the people who came to IIT Delhi. Whereas the children of government employees, they went to other IITs, but IIT Delhi for some reason attracted all these business communities. So they came to IIT, got a degree, but then it's all in their genes, right? When they go out, the degree did not matter. That gave them the stature, and then that gave them the networks and all of that. They went out and created the businesses. So that is what has made IIT Delhi different from other IITs. So therefore, India, that entrepreneurship runs in our genes, and that is what we need to be able to utilize when it comes to the deep technology innovation and create funding models, the government support. Some of these things need to happen. Unfortunately, they are not happening as much as I would have liked, but at least certain things are moving in that direction. I will also tell you some of that with my own examples and all that. So having said this relevance aspect of it, right? How do you bring relevance? So I actually did a informal survey of my own, talking to all my faculty colleagues in different institutions and finding out, talking to their PhD students and trying to figure out where did they choose their research problems from, right? A PhD student, I asked a PhD student, who gave you the research problem, right? And then, in 70 to 100% of cases, depending on which institution you go to, most of these problems actually originated in library. They all came out of reading research papers, right? So that is what is the situation in most of the universities. So that is something that needs to change in our academic institutions. What is the other way, you can actually pick up research problems from the society, right? You can create schemes where these students and faculty can go and work in hospitals, can interact with outside stakeholders, and then through those interactions, you can actually find a lot of good research problems. In IIT Delhi, we started this immersion program. There we had the All India Institute of Medical Sciences just next door. All India Institute of AIIMS and IIT Delhi did not have any strong programs between them. Everything was informal, right? But then we created MOUs, we created funding models. AIIMS funded their faculty to collaborate with IIT. We funded our faculty to collaborate with AIIMS, and that little bit of money, made a huge bit of difference. Then we created immersion programs where students can go and be with a doctor, with a surgeon, understand how medicine is done, and that made a huge difference for the institute. And then we also started a program called GRIP, Grassroots Innovation Program, where since you have students coming from all over the country, we ask the students coming from a certain region, can you pick up a problem which exists in your local area and use the IIT resources to actually solve them, right? So once we told them, then they got very excited. We started funding them a little bit of money, and some of these actually made a huge difference. And the humanities and social sciences, that's the department which is like our window to the society. There are many good people in humanities departments who actually understand what happens in the society and all of that. as engineers, we have lost that human kind of a thing. Having been working with the machines, we also become like machine. Other day when my wife was sent a photograph, what impressed me was the quality of the camera. I was not even looking at I was not even looking at what was there in the photograph kind of a thing. And after 25 years of training as engineer, you only focus on machines and technologies and all of that. But whereas the humanities people are still connected, they are very sensitive. I think getting some problems from them, making them work with the engineers is another way you can actually become more connected with the society. So multiple ways you need to connect people with the society. And it was during my time that we started this Unnat Bharat Abhiyan at IIT Delhi, where we said higher educational institutions will connect with the rural areas, try to pick up problems from what is happening on the ground and work on them and provide solutions to them. Government of India also gave money for that, and we involved multiple institutions and all of that. Other way, of course, is industry. But that is somehow in India there is a huge bit of a problem between academia and industry collaboration. Just 4 days ago, I was in a CII event in Delhi, their annual general body meeting, and there again we were discussing the same thing. I said the same discussion would have happened 50 years ago in the same annual general body meetings, but nothing is actually changing. No industry is coming forward and investing money in academia. And I have always said that somehow government wants a kind of a love to develop between academia and industry. Right? They want some love marriage to happen between academia and industry, which is not happening. We have waited for so many years and nothing has happened. I think what we need to do is, government needs to say that a percentage of CSR must be spent on the academic institution. So that if you mandate industry to spend a percentage of CSR on academic institutions, I can tell you in no time the love will develop, arranged marriages will happen. As we all know, after marriage the love happens in many of those arranged marriages. So that is what eventually will happen between academia and industry. Unless government mandates such kind of expenditure on academia from these industries, nothing is going to change in this country. They will always find ways not to spend money on the academia, but spend it on any other thing. In fact, I even did that survey once on. If you look at their budgets and all of that, and their annual returns and all that, many of them are spending more money on travel than on academic institutions, in funding academia here. Take any multinational. There is no multinational in this country which is actually spending more money on academic research or academia than on travel kind of thing. So that is the situation in the country. In fact, once when a member of parliament came to visit me when I was a director, I actually asked her, may I know why don't you raise this question in parliament? Just one question on what is the money spent by corporate on academic research in India, on academic institutions. One question in the parliament, make all these industries give exact figures of how much of money is spent on academic institutions, the entire truth will be out. Right? The whole country will get to know that some of them have spent zero money on academic research. They haven't even bothered to know what is happening in IASC by sitting next door to IASC kind of thing. But then she immediately said, no, Professor Rao, if I do that, I will be branded as anti-corporate, and then in the future, then I will not be eligible. Nobody will make me a minister on the corporates to collaborate with academia, which is unfortunately not happening right now. And with these very mild policies and asking them to collaborate for the past 50 years, we have been doing that, but nothing is actually changing. And that is something that needs to change for our academic research to become relevant to anyone outside the peer community. And so we started again at IIT Delhi. We did multiple things. The professors of practice is a great scheme. In IIT Delhi, we said 10% of our faculty can be professors of practice. And some of them we recruited have actually transformed the culture in the departments. Just one or two people who are excellent people, who everybody respects in the academic community, though they come from the industries, have made a huge difference for the whole department. I think this process of practice thing, after we did it at IIT Delhi, of course, Professor Jagdish Kumar is from IIT Delhi, he started it for UGC, and then I hope if done well, that can also be a game changer for the country. And we did many other things, I won't get into that. But the fourth thing is the strategic agencies, collaborations with the strategic agencies. I can tell you DRDO, ISRO, they have enough money, right? And most of that money goes towards internal research, funding their own laboratories. And but if you can collaborate with them, if you can convince the chairman DRDO, lot of money can come for them. A few hundred crores here and there is not a big deal. At IIT Delhi, for example, we started the Joint Advanced Technology Center. During 4 years that I was there, about 270 crores of funding came from DRDO for projects in IIT Delhi. About 100 faculty members, 150 PhD students started working on DRDO funded, DRDO defined problems. And that made a lot of difference for DRDO and everyone. And I think some of these need to happen. And unless these are mandated to happen in some way by some funding kind of schemes, I don't see by picking problems from libraries, anything that originates in library goes back to library. So nothing else will happen in between, and I think that has to change in our academic institution. Otherwise, there is a lot of talent in the academia, and you give them the right set of problems, great things can be done. But unfortunately, we are not utilizing this resource as much as we would have liked in the country. And even in the national education policy, the National Research Foundation is exactly supposed to be doing that. I have always argued that what is the reason why this is not happening, that connect with society or industry or societal problems is not happening. Because of the way government funds research in India. Where do you receive most of your money? From Department of Science and Technology, right? Almost 70 to 80% of research grants come from Department of Science and Technology. What problems do they have which they can give you? They can give you money, but they don't have any problems. DST comes under Ministry of Science and Technology. Ministry of Science and Technology has no connection with any other ministry. You go there with your own problem as a project proposal, and who will review your problem? People like us again. Sometimes I sit on that side, many of us sit on that side, sometimes this side. We distribute the money, whatever that comes to that. So we define the problem, we go to ourselves and get it funded, and then we do the research and we publish papers. And who needs them? Again, the same people who are also uploading your project. So we have created this nice cozy circle that we don't even know what Ministry of Railways wants, we don't know what Ministry of Agriculture wants, we don't know what the Ministry of Heavy Industries wants, because making two ministries work with each other is more difficult than making two institutions work with each other. I can tell you that. I mean, IIT Delhi and AIMS, we could easily connect and talk to each other and do a lot of things together. But getting two ministry secretaries to talk to each other is such a big challenge in this country. So therefore that won't happen. And this entire funding model for India for research is completely flawed, which is not connected to anything that is happening in the society right now. And what is this National Research Foundation actually supposed to do? If you read the document carefully, many of us were involved in conceptualizing that each ministry has to allocate certain amount of money to NRF, every ministry. And while giving money, they will also define the problems. They will give the problems, they will give the funds, and then they engage academia to solve those problems with that money. When that happens, I can tell you, a lot of good things can happen. These ministries, other than EST, right, other than DBT, no other ministry has any formal ways to collaborate with academia. No formal ministry. Sometimes you might receive some grant from Ministry of Textiles. That is because some secretary of the day thought that he or she should interact with academia, or minister would have told that person. So they launch a project funding scheme and then they fund projects. But once the secretary goes, maximum 2 years, right? That's what the ministries change, secretaries change. After 2 years, nobody will even ask you what has happened to your project, whether your next installment has come or not. Nothing will happen because nobody cares in those ministries, collaborations with academia or funding the academia. So I think given that kind of a scenario right now, the kind of a vicious circle that we have created for ourselves, we are not going to be effective in dealing with the societal problems. And so a lot of research will happen, which is what is happening. Our rank in the world when it comes to research papers will continue to go up. We are already ranked third in the world right now. Then the quality of research is also going up. All that will happen, but then our visibility in the society will still be very poor. Our visibility in the peer community will continue to grow, but our visibility among the stakeholders, among the society will still be very poor, because nobody will be able to say with enough confidence, this technology I developed has solved this problem in the country. That is not going to happen unless we change some of these fundamental flaws that exist in the country. And in NRF, is a solution to that problem, but then it's already 3 years since the national education policy has been announced, and I don't even know why NRF is not announced, and anyway, that's a different story, for some other day. Another major thing that is also lacking in academia is filing patents, right? In US, for example, I have this data. I work in the nano kind of areas, and this is for 2019 nanotechnology data. India in 2019 wrote 15,000 papers with the word nano in them, right, in good journals. How many patents did we file? We are ranked third in the world, right? We are ranked third in the world. How many patents did we file for 15,000 papers? 54 patents. Right? That's all the patents that we wrote out of this many papers. Look at US. The same year, US wrote about 24,000 papers, ranked second in the world. How many patents did they file? 4,666 patents in the same year. For every 5 papers in the US, they file a patent. Because when they generate knowledge, they also protect the IP in that knowledge. Whereas in India, our patents are very kind of a culture. So in many departments, like paper is ready, where is the data kind of a thing. That's a joke about chemists in this country. The paper is ready, where is the data? So we are always in a rush to publish papers, and so that is what happens in many of these cases. When it comes to publications, and so we are giving away all the IP. We are not really protecting any IP. Unless you protect IP, there can never be a deep technology startup. If you are ever imagining starting a company in a technology space without the patents, there is no startup. Because even if you start a company, nobody will fund it. Because any investor would only ask, do you own the IP for the technology that you want to commercialize? And if you don't even own the IP, there is no question of any VC, any angel investor, anybody touching your company with a large pole. So that won't happen. So therefore, filing patents is the first step to any technology activity, any commercialization activity, and there we are failed. IIT Delhi, when I joined in 2016, IIT Delhi was filing about 15 to 20 papers, so 15 to 20 patents, right? And by that, so we then tried to do a survey, ask faculty why is it that so few patents are filed. You find out. You basically see that it's taking a long time. That is often the reason why people don't want to file a patent, right? If I have a paper ready, the student wants to publish a paper because after all the student needs to graduate, and if you tell the student, it takes 1 year for me to file the patent, neither the faculty member nor the students, nobody is willing to wait. And therefore they want to publish the work and they're not worried too much about patenting and all of that. So all that was required was to reduce the time frame to about a month. We said, you write a paper, you hand it over to these attorneys, they will convert that paper into a patent, they will file the patent. Once you file, you are done. You don't have to worry about its publication and all of that. Once it is filed, and then they tell the faculty member to go ahead and submit the paper, and it's all done. So once you reduce the time it takes for patenting, I can tell you, the number of patents will go exponential. So in addition to that, you also bring in awareness. What can be patented is something that not everybody is aware of. You need to organize more awareness for shop, and you need to reduce the time required for patenting. Because what is required to write a paper is exactly the same thing that is required to file a patent. Right? Every paper you write, you are always claiming that I have done something new. Right? If you don't claim that, no reviewer will actually publish your paper. And in a paper, you tend to make it so complex that even reviewer will not understand and accept your paper. So that is what scientists always do. That, right? So therefore, that's what is required in writing a paper. The same process. Once you have a new idea, after all, which we will have anyway. So therefore, we looked at IIT Delhi. Once we fix these problems, from that 15-20 patents, IIT Delhi, when I left in 2022, filed about 170 patents. Now 10 times increase in the number of patents. All that we needed to do was just fix these minor kind of issues, and that was all what was required in order to file these patents. And that is what, in my opinion, is what is required. And I always say that patents to publications ratio is actually a good metric. Right? How many papers are you writing? How many patents are you filing out of that new knowledge that you are generating? That ratio in India, as I showed you, is 1 in 300. For every 300 papers, we are filing about 1 patent. Right? And in US, that ratio is 1:5. For every 5 papers, they are filing a patent. And the optimum in India, maybe one is 20. You can set a target for yourself. Let's say for every 20 papers, I would like to target one patent. And then, you bring in that awareness and fix those problems. I can tell you, you can actually easily meet that kind of a target. And once you have enough patents, then there will be more, there will be IP, there will be more startups, there will be more, technology licensing. All of that will happen. And unless you have about 1,000 patents, you can't even expect any revenues for any institution. There are enough studies done to show that only when you cross that threshold of about 1,000 patents, right, that is when you will start thinking of the IP, the revenues will start coming in. Because you then create a portfolio of patents, you approach with that portfolio of patent different industries, you have technology transfer offices, all that process can begin only when you file, only when you have enough of patents in the system, to actually talk about. So some of these are the things that one needs to do. And now having said all that, let me tell you about my own story of how I started to do some of these. So I joined IIT Bombay in 2000 when was it? No, not even in 1998. So the 1998 I joined IIT Bombay, and then but all of us could have worked somewhere, and we brought the problems from there. We even brought the samples from there. That's the only difference between most productive person and less productive person. If you have your own devices, then you don't have to worry about anything, right? You get money from DST, you have those advanced devices from the US, and then you can write any number of papers. That's what I did. And for the first 7-8 years, I could write as many papers as I want, because I had all the samples which nobody else had in the country, or even in the world, very few people had access to that quality of devices that I had. And obviously I got many recognitions for the JNT, but never all that happened with just that work which I borrowed from the US and did in India, nothing else. And around 2005, 2006 kind of a time frame, then I asked myself that question. It's okay, now I'm writing enough papers. Most of my papers are in IEEE transactions and those kind of good journals. So now what next now kind of thing. So then that is when we started to look at other ways of doing research. So my research, if you see, I work on 3 different areas. I started with nanoscale devices, and I collaborate with all these industries, Infineon, Intel, Applied Materials. So all these nanoscale devices, CMOS work, I collaborate with these industries. They funded me, but the funding you receive from these industries is not whole lot. And in fact, from Intel, I would have received maybe about how much money over my 15 years of collaborations with them. I have received about $400,000, right? That's all. $400,000 is about how much? About I don't know how much is it. So a few crores of rupees, and so that's what I received from Intel. But then I filed 10 patents with them, about a dozen patents with them jointly, and much of that IP was very valuable for Intel. In fact, this is a letter from Intel which actually stated that the patent IP that we generated was implemented in hundreds of millions of devices with all those patents and all that. But for $400,000, they could actually gain so much out of that research. And what has India gained? Nothing. India hasn't gained anything out of this. But of course, we buy those chips, and many of them are low power SOCs. So you have them in multiple areas and all of that. But that was a satisfying kind of a thing. I received some international awards, recognitions from Intel and all that. But otherwise, it did not really make much of a sense. And I would have continued working in that area forever, because industry was very happy with me. They were continuously funding my PhD students. I had no problems at all. But then at some point I decided that what is that I can do which can benefit the country here, which can benefit the society here. The CMOS, we don't have any semiconductor manufacturing. Even now, we don't have anything like that. So therefore, I realized that just working on the same problem forever is not going to make any impact locally. And of course, I know many colleagues who have worked on the same postdoc problem forever until their retirement. But at least I woke up early enough. So after about 10 years, I decided that I want to now branch out into different areas and then do different things kind of thing. So I started working in the sensors area. I will then tell you a little bit about it. But the sensors is also micro nano fabrication. The concepts are all borrowed from the CMOS, which was my primary research area. So I borrowed some of those concepts here, started applying to sensors, and then I also work for integrated the sensors and CMOS and a lot of interesting stuff we did. But in this talk, in maybe another 15-20 minutes, I will talk about the sensors work. I'll skip this. I always talk about the 5 technology platforms which I believe are very important for the students to know, right? For example, India started its knowledge economy, that journey with the IT industry. It all started with that Y2K problem, the year 2000 problem, and rewriting the code for banks and everybody. That is how India, acquired that IT kind of a skill and started doing that. And then came the biotechnology. So India does very well in the IT. We are after all the world leaders. We exported as much IT as Saudi Arabia exported the crude oil. So that way we are a superpower when it comes to IT. And then comes the biotechnology. We are again doing very well in the biotechnology, in the manufacturing. A lot of drugs, even the vaccines. After all, we are one of the very few countries in the world who could develop our own vaccines and administer them with enough confidence. So I think that way India also has a good track record in the biotechnology space. And then comes the nanotechnology. Here we are ranked 3rd in the world, but nothing much has changed when it comes to that knowledge to wealth translation. There aren't any noteworthy startups in the nanotechnology space. And then comes the cognitive technology, the AI ML kind of a space. Here again, we seem to be doing pretty well. We are ranked 5th in the world right now for citations per paper. Looking at the citations per paper as a metric, India ranks 5th in the world. There's no wonder, because much of this research for AI ML, it all happens in computer science departments. They are the ones who do. Computer science departments are pretty good. Any IIT, any NIT you go, top people in the computer science departments. After all, they get the best students also. So obviously, they get good talent and they do great kind of work, and so the quality is very good. But the number of good computer scientists is pretty tiny in this country. So there are very few people. So if you look at the total quantum of research happening, we don't compare anyway. But you look at the quality of research happening, we are definitely among the top 5 in the world when it comes to the AI ML kind of research. And then comes the quantum technologies. Government of India has launched 6,000 crores kind of a vision now for quantum technology. And hopeful BITS and MNIT will be collaborators, and we will write some joint proposals to DST for a big quantum kind of an activity. So all of us are now trying to see bring together the quantum related people in our areas, in our institutions, and bring them together and seek some funding and all of that. So we have a strong tradition of basic research. We should also be doing well in this space. But all of this, except the first 2, where things have happened on the ground, there are a lot of manufacturing industries, a lot of jobs available. But then in these 3 sectors, despite billion missions, $1 billion kind of missions, there aren't any jobs right now. And the reason again for that is that research to innovation, that thing is missing. A lot of research is happening, but nothing is getting converted into the wealth kind of a thing. And unless you start companies, these companies start recruiting people, you don't really expect anything to be changing on that front. So these 3 areas, we still have a long way to go for that knowledge to wealth translation. But if you look at India, India has actually done well where clear goals are set. We are the same country, right, where there are ISRO, launching space missions, DAE building atomic reactors, DRDO building missiles. How is that all of that is happening? If you actually work with this industry, these are our own students who are actually working there. So what is that they suddenly become so good in technology there, while they are not able to do anything from their academic institution? The only difference is India does very well where goals are set. Now we just need proper goal to be set. If a proper goal is set, right, then multiple people working together, we can actually do and then finally realize that goal. The ISRO, you might have any number of laboratories, 15 labs, 14 labs. At the end of the day, you need to fly a satellite. If you cannot fly a satellite, nothing matters. You say that I have written 1,000 papers, I have filed 1,000 patents. Who cares? If your satellite is not flying, nothing really matters. The government will basically, wind up the entire ISRO kind of a organization. So there, the clear goal is that whatever you do, whatever you may do, finally it has to get into that satellite, it has to fly, right? Once those goals are set, we do very well. even DAE, even look at DRDO. So the Indians do very well where the goals are clearly set. Whereas in academic institutions, there are no goals. Nobody is even asking us to solve any problem, right? So therefore, why should we even be bothered about setting goals for ourselves? So this is the fundamental difference between wherever we have succeeded, where there are clear goals set, Indians do very well. Where there are no goals, we do all over. Nobody can control us now what problem I can work and what I want to do with that problem. So that is the fundamental difference that exists in the country right now. So, but then at least in academia, at least at the DST level, whether if you look at the NSF, if you look at the US funding models, there are many funding models there where clear white papers are written, clear goals are set that we want to be able to do this, the clear mission goals are set, and then you involve academia to actually deliver on those missions. Of course, the basic research happens, all of that is fine. But if you ask me, there is nothing like basic and applied. There is only good research and bad research, right? Even the Einstein's, gravitational waves. 100 years ago, Einstein proposed gravitational waves. That was nothing can be more basic than that, right? I mean, what use is it, to know gravitational waves out of something colliding in deeper space and all of that. But then the same gravitational waves after 100 years, once it is proven. Of course, people got Nobel Prize for that, but now that has become a tool to explore the outer space. In addition to telescopes and all that, now gravitational waves has provided an additional experimental tool to know what is happening in the outer space. The quantum, right? Quantum has always, nothing can be more basic than the quantum research. But now everything is quantum. Quantum computers, quantum communications, quantum technology. So I don't believe in this basic research and applied research. Good research can one day be directed towards generating providing solutions to some problems. Sometimes the lead times are very long, sometimes it can be quick. That's the only difference. And otherwise, good research is always useful, and we should fund all kinds of research for that matter. The nanotechnology, like I said, we are ranked third in the world, and there is also a nice, kind of a data available on the web. The nanotech, somebody has plotted the technology development strength versus the nanotechnology activity. So how many papers, what is happening in the world in the nanotech, and then the technology, this is all technology, and the technology development strength of countries. They categorize countries into 4 quadrants: the minor league, the niche players, the dominant players, and the ivory towers. So when you look at it, where is India here? India is here, the minor league, right? At the bottom of this minor league, and so our technology development strength is pretty poor. So while we tend to do a lot of research, but we are not able to convert that research into technology, right? But when I showed this slide to somebody, they said, but why are you complaining? Where is the company of Canada, Australia, Russia, China? So they are also not doing anything. We are also not doing anything. So but the difference here is a lot of research is happening here. But if you look at the actual technologies that come out, which are impacting the world, most of them will happen, if you notice, from one of these 4 countries: US, Japan, Germany, and South Korea. Look at all the new age startups, the Teslas and Apples, all of them have come out of one single country, right? So which are all like the most valuable companies in the world today. And that is what basically is the difference. So you want to go from this minor league to this dominant kind of players, and there is so much to learn by studying the way they fund research, by the way the universities connect with the society. So a lot of learnings can happen out of this kind of a process. So now, having said all this, let me, I'll skip this because I don't think I have so much time. So I will tell in the next 10-15 minutes, what I do, how I actually work in some of these kind of areas. So therefore, the point I am basically making is, to be impactful, it's important to connect with the society, pick up societal problems, right? Pick up societal problems, work on them as a multidisciplinary team, and use startups as a way to let the technology go into the market. So that is a kind of a model which has definitely worked very well for me, and to many of my colleagues who I know have also done that successfully. So that is a model I am basically advocating. How do you pick up this problem? There are enough problems in the society. In fact, I always say that if you are looking for a problem, you don't have to go to US journal and find that. All the world's problems are in India. If you are, India has all the problems of the world. So therefore, you just need to look around you, you will find a problem. And then you can actually spend your lifetime solving those problems. take the case of agriculture, right? There are just so many problems in agriculture in boosting the productivity, the precision agriculture. You can spend your lifetime working in the agricultural sector. The same is true of healthcare infrastructure. The same is true of the security. The same is true of energy. The same is true of water. Any of these problems, you can actually spend your lifetime. These are all of them require deep technologies, right? And to actually solve any of these kind of issues. So therefore, having said that, I also have given you any kind of information about all of this. I don't have much time. So, in fact, one of the very first problems at IIT Bombay we chose. I was an associate professor at that time. So a few of us came together because there was a strong urge to do something which has relevance for the society. And then some of us in faculty, we all came together and we said, what problem do we all work on, right? And then one of the problems we started to look at is, we said the cardiac diagnostic system. At IIT Bombay, one of our colleagues in EE during the MTech interviews, actually had a heart attack. And then that person said, I have been having this chest pain, that perspiration and all that for a day or more, but I did not go to doctor. And he suddenly fell ill and we had to rush him to the hospital and all of that. Then we started talking to the doctors while he was being taken care of. And that is when the doctors told us, this is a big challenge right now. If somebody is having that silent heart attack, there is no way of knowing. And by the time we bring that person to the hospital, sometimes it might be too late. So one of the things they said was, if only there is a simple device that with a simple blood test, if I can diagnose what is happening to the heart, right? Because when what happens in all these cases is, when there is a myocardial infarction, when the cardiac muscles, when the cardiac muscles are dying, right? And then they basically release certain proteins into the blood. And when the cardiac cells are dying, they release certain proteins into the blood. So these proteins are like troponin, myoglobin, CKMB kind of thing. And they said, if there is a simple instrument, I can do a blood test. This person has come now. I do a blood test, and I know whether what the concentration of these markers is. If it is high, even if ECG is normal, I know that something is wrong with the heart, and then we will take care of the person, whether a bypass or if something can be done. But in the absence of it, now I need to send the blood sample to the laboratory, right? And that laboratory will give me the results after 4 hours. And for 4 hours, I can only do ECG, but I don't really know what else to do kind of thing. So that is when we thought, can we actually define a problem where we can detect some of these markers required for detecting diagnosis of myocardial infarction, and then make it like a lab on chip kind of a concept. So that is where the problem actually came from. And then we started to work together. We said, we called it iSense, standing for infarct sensor. And we said blood sample, input filter, you filter, take the serum, then having the microfluidic channels, and then the biosensors for each of the cardiac markers, and then this entire thing as a disposable chip, and then a small tabletop instrument, exactly like the glucose testing that you do, that we all do at home when required. So that was a kind of a chip. So we actually started with a block diagram. We said, this is what we want to develop, this is what the chip should look like, and this should be the cost of the chip. We said this entire test should be about 100 rupees. The moment we fix the price point as 100 rupees, the moment we said that this has to be a disposable chip. Why disposable? Because we are using human blood, we cannot reuse that. So therefore 100 rupee per test, a disposable kind of a platform, and then a small tabletop system for electronics. So that will not be a big challenge for many of us coming from EE. This is like a BTech or MTech kind of a project. But the biggest technology is here, to detect those cardiac markers using a sort of a kind of a chip which is now very specific to some of these markers kind of thing. So that was a problem that we set for ourselves, and we had 6 different departments involved. We had people from mechanical engineering working on these filters. Amit in mechanical started this work of blood filtration because of this project. Now we got a Bhatnagar prize for the same work after 10 years of time and everything, because we needed a very low cost chip from which we can take the blood in and then the serum out kind of thing. So that technology he could develop. In mechanical engineering, we had people working on the microfluidic channels. In the chemistry, biology, in physics, in metallurgy, because there was a lot of materials people required, material science departments, we had people working on the materials, on the packaging, on building the platform, on electronics, of course, doubly. So we had at least 6 different departments, their faculty and students involved. We wrote a proposal to National Program on Smart Materials. There was a DRDO program at that time. We got the funding for this, and then we started working on this. So the working on developing the complete chip. Our goal was, while doing this research, there is nothing available like this in the world, at least at that time. When we started the project, this was in 2006, 2007 time frame. There was nothing available in the hospitals anywhere, and we said if we can develop it, we will be very unique and it will save lives, and that was the whole idea. So we started this project, and then in my group we started working on the cantilevers. We said we will use these tiny piezo resistive cantilevers made out of polymers. I come from a strong silicon background, but I said silicon will not work for this application because it's a disposable platform for 100 rupees. Silicon is an expensive piece of material. Using it for a one-time use is never going to be commercially viable. So I moved away from silicon, started working on polymers, making these nanostructures using polymers and all of that. That made my research more intensive, more exciting. I could publish many more papers than if I had worked on just the silicon kind of cantilevers. So it made it very innovative. So we did a lot of research. I'll skip some of this. All this is anyway. We published a lot of papers on that. So we did this research, and then we built platforms. So I'll skip it. We built platforms. We actually showed in some of our papers that this is the world's most sensitive platform for detection of proteins. So that when you have a protein binding on the cantilever surface, the delta R, these are all piezo-resistive platforms, the change in resistance for a protein binding happening on the surface of a cantilever, we showed that that's the highest compared to anything in the world. So we actually claimed it in these papers, showing what others have shown and what we have done. And then that was interesting research. And then we also finally built the electronics as well for that small instrument, the electrical system. We actually developed the complete prototype. So this is developed under the iSense project from NGSM, NPMOS. iSense, this is how the cartridge looks like. You put the drop of blood and it connects to this system. It actually can measure the cardiac markers, 2 cardiac markers. And that we developed. And then we started a company, Nanosniff Technologies Private Limited. We transferred the technology to them. And at the end of the day, after almost like 7-8 years, we have a platform now with which any surface reaction I can electrically measure. As long as the surface reaction is selective, I can detect anything. The selectivity comes from the coatings that you provide on the surface of the cantilever. So we did that, and then around that time, there was some bomb blast in Pune. The security people came to us in IIT Bombay and said, now that you have a platform for detection, can you build an explosive detector, like electronic sniffer, like what the sniffer dogs do? Can you develop something similar to a sniffer dog kind of a thing? And then we started working on that. We said that we will use our same platform, but what I quote on the cantilever needs to have an affinity to those molecules need to be able to bind to vapors of explosive, right? The vapors of explosive, so therefore what will bind to the vapors of explosive? And that is where we started to work with the chemists. The chemists came up with a lot of interesting problems, because if you look at any explosive, right, look at TNT, RDX, PTN, carbon, hydrogen, nitrogen, oxygen. These are the common elements in all these explosive materials, and even the shoe polish will also have similar elements. So you are essentially doing a molecular recognition on the surface of a device. If I can do that recognition, if I can selectively bind that molecule to my receptor, right, and then the resultant reaction is what I can capture electrically. But what do I need to code so that I can do that molecular recognition on the surface of the cantilever? So that is when I interacted with almost every leading chemist in the country. Lot of research we did. We published many papers. These are all the molecules people synthesized for us, and we then did experiments with the explosive molecules, captured the binding events, published papers. All that was working fine. We were able to write lots of good papers. And then we also started to work on electronic nose. Instead of one molecule and one recognition, we had multiple cantilevers here, multiple coatings, so that when the explosives come in, they bind on all of these cantilevers, which have different coatings, and then we do a pattern recognition. So that is what the electronic nose platform we developed. So we did a lot of research, but finally when we gave it to security agencies, they said, sir, 80% is okay, but 20% false positives. In 20% of cases, it actually detects other molecules as explosives. And they said, no, for us to use it in an airport and that kind of a place, it's very difficult to use because your system, shows many other normal molecules, normal, vapors as explosives. So therefore, they felt that it cannot be used outside the laboratory. And first, once we went to field trials, what worked very well in the laboratory in a very controlled setup did not work once we went outside the laboratory. So we then said, what else can be done? So we were not really willing to give up. And then we had a very interesting idea. One day when we were discussing and debating this problem, we said, until now the approach was always chemistry, right? You have a molecule which binds to the vapor selectively, and so that is a kind of an approach. We said this is not really working, so therefore, what can be other alternative? While chemistry can fail you, the physics will never fail. We were actually looking for more physics-based kind of an approach. What is the physics here? The property of an explosive is actually to explode, right? So therefore, when a person walks in the room with an explosive, you are collecting the vapors, right? And you are getting all those vapors in, and then you now cause an explosion. You collect, let us say, 5 nanograms, 10 nanograms of this explosive material and explode that material. When these materials explode, these are all high energy materials, they release temperature in the ambient. You measure the temperature change using a temperature sensor. So our simple idea was you explode the material at 5 nanograms, 10 nanograms level. The released energy is what you detect using a temperature sensor. So that's what our idea was, and so we built all these sensors for explosion. How do these explosives explode? For that you need to give it a thermal shock. So you need to rapidly heat it from room temperature to 400 degrees centigrade in a matter of milliseconds. And when you give that thermal shock, the explosives will go through what is called deflagration, and that deflagration will basically release energy. You are detecting that energy as a temperature change. So that was the whole idea here. So we built devices for that, and we then were able to successfully demonstrate that this actually works. And I have a small video to show you.
How technology. An IIT Bombay incubated company jointly manufacture and launch Nano Sniffer, an advanced and affordable explosive trace detector, screening visitors and passengers for explosives at various public or crowded spots have become the norm due to the increase in the terrorist activities around the globe. Every luggage and person passing through the security checkpoint is tested by the security officer to check whether they have traces of explosives on their surface, skin, or hair. Nano Sniffer proudly claims to be the first explosive trace detector in the world using microsensor technology. The microsensor of Nano Sniffer is made using micro-electromechanical system, MEMS technology in semiconductor fab. The sensor uses fabrication techniques such as lithography, etching, deposition, spin coating, and finally released to the microsensor. The core technology is protected by patents in the US and Europe. All of our actions leave trace behind, which is then screened by the security personnel. The security has to concentrate at the sampling areas that are likely to be touched by hands. In the case of a bag, this will include handle, buckle, and zipper. Post-sampling, the swipe is inserted into the system where microheater subjects the particles into rapid heating. In case of explosives, this triggers exothermic reactions which are picked up by the integrated temperature sensor of the microheater, thereby landing each compound in its own thermal signature. The algorithms use these signatures to distinguish between explosives and non-explosives. Further analysis of the algorithms help in categorization into the appropriate class of explosives. The follow-up few Nano Sniffer features. It is the first microsensor-based ETD. It detects and identifies explosives in less than 10 seconds. Identifies and categorizes explosives into different classes. Can detect ng quantities of explosives traces. It detects all classes of military, conventional, and homemade explosives. It is portable and affordable. It gives visible and audible alerts with sunlight readable color display. Nano Sniffer, explosives trace detection technology can be deployed at airports, railway stations, ports, malls, metro stations, corporate parks, hotels, and tourist spots. The goal is to intercept and prevent access of explosives trafficking. Nano Sniffer is 100% made in India product.
So this technology is completely disruptive. There is nothing like that in the world. Nobody had ever thought of exploding an explosive to detect it. Nobody has done that. So we now have a system, a complete product on that, and a lot of airports, we have the US patent and European patents already granted for this technology, and this is released now by Government of India, and now almost 11 airports have bought this technology, and now more airports are asking for it, and this is a very low cost. What is there inside? There is nothing. A micro heater and then a temperature sensor, and many of you who do micro fabrication know that the bill of materials for these in a large scale wafer level manufacturing can be a few tens of rupees to hundreds of rupees, and that's the beauty of it. So now it, nobody is able to compete with us on any tender, and therefore we now get all the orders wherever we need the specs now, and so things are looking very good. And so now I'm working on converting that into an IoT node, miniaturizing. The good thing about electronics is you can keep making things smaller and smaller. So I've been quite a bit of now a lot of my students work on doing this, and the only way, one of the challenges in developing this is you want to put it in buses and trains and all these places for detecting explosives if somebody is carrying them. But then how do you power them? They require battery, they're like mobile phones. So we are trying to develop energy from the vibrations. From the buses and trains, when there are vibrations, you can convert that mechanical energy into electrical energy, charge the sensor, so that way it's continuously getting charged, whenever the vehicles are moving. And so that's a kind of a technology. So I do a lot of research on piezoelectrics from that point of view. So now everything is that way directed. And then about 7 years ago now, when I moved to IIT Delhi, between IIT Delhi and IIT Bombay, we started a large project on agricultural sensors. But again, the goal is same. So we are not doing this research to publish papers. We are basically, we took the soil health card, which Government of India has given to all the farmers. We said, what are the parameters in the soil health card? This is how the soil health card actually looks like. We said, can we develop sensor technologies for detecting all of these micro and macronutrients, which can fit into a small suitcase, right? Which are very easy to use in the field, that anybody in the village should be able to do the test themselves. You don't have to send the samples to an agricultural lab and all of that. So very focused project. Again, we involved multiple people from IIT Delhi, different departments, IIT Bombay, different departments. Whoever said that I can detect this kind of a micro or macronutrient, we involved them, we funded them, and then we started developing. Goal was to develop 4 prototypes, one for volatile tracking, pathogen detection, macronutrients, and moisture, pH, and salinity. So after starting the project as a joint project between Delhi and Bombay, I was focusing mainly on the NPK and the soil moisture sensors. And I started my second company in 2018, Soil Sense, which is on the agriculture kind of a thing. We last year launched this product called NutriSense. It can detect nitrate, phosphate, potassium, NPK, and the pH of the soil, and of course the electrical conductivity and other parameters. And this is again, this is based on electrochemistry. We tried multiple approaches. Finally, electrochemistry worked for us, and so we now can claim to be 3x cheaper compared to similar NPK measurements, 10x cheaper compared to global, meeting all the standards that are required, for the field use, on-site rapid soil analysis. And then we are now, the Soil Sense has recruited enough people. They are training the village level people to do tests on their own. Now we are working with other startups. Now this technology is already commercialized. We also have soil moisture sensors, the weather stations. So this company is doing pretty well right now. We have done a lot of field studies and all that. The Soil Sense is now working with all of these big players who have interest in agriculture. So therefore this is the whole idea. Pick a problem from society, then have a multidisciplinary team to work on it. All of this takes time. The first technology nano sniffer took us full 10 years. 10 years. So the second technology took us almost like 6 years. From the proof to from the idea stage to launching it in the market. Nothing, first one 10 years, we learned a lot of things in the process. The second one about 6 to 7 years, because we had some clear experience and we had some track record. The same investors were also willing to fund this company, and we had, we knew how to do things better. So therefore it took us about 7 years, I would say. And I think that is the time it takes for any deep technology to get into the market, and you have to continue to work on it for a period of time. And so therefore, I worked on multiple prototype kind of an activity. And at IIT Bombay, particularly, we built that culture because we were doing it as a multidisciplinary. So many people started doing something similar. And so my first company, Nanosmith, is doing very well now. Now they are not even a startup anymore. They are a full-fledged company. They operate out of the IIT Bombay technology park, and this is their major product. The cardiac thing, it is on the back burner right now. We have, because the hospital trials is a big challenge here. So they want to earn enough revenue from the explosive detector, which is now selling very well, and then invest it in the cardiac thing and take it forward. They are launching now multiple other products that way. So they have all these products now which are doing well. The second company, Soilsense, is also doing very well. So they are now selling many of these technologies in the market. And now I am taking things forward, more impactful kind of projects in all of these kind of areas. And I'll skip this. I think maybe just one slide I have. I think I always said that our academic institutions need to become idea factories, and for that, the connect with the society is important. The first project that we did entirely came as a requirement from medical hospitals. The doctors said that this is what we need. The second project came from the farmers, right, and the government of India, the Ministry of Agriculture, saying that this is what we need, kind of thing. And I am currently working again on another technology, but again, that collaboration with the outside stakeholders is therefore very critical to identifying the problems. And that's what I do. I call it the idea unlike minds kind of an approach. Unlike in the sense of cultural backgrounds, unlike in the sense of disciplinary training, the multidisciplinary training groups, unlike in terms of different attitudes. People from academia working with industries. Again, that's also, they think very differently from how we think. I think when you have all these unlike minds coming together, that is when you get ideas. And if you can put in place proper mechanisms to encourage these deep tech startups, either to, we launched a program called FIRE, Faculty Innovation and Research Driven Entrepreneurship. That is a program I initiated at IIT Delhi, where we said any faculty member who wants to start a company, we provide a seed grant. And to encourage the faculty member that, this is a seed grant you can start with now, but within about a year, using this seed grant, you should incubate a startup. That was the whole deliverable. And so that many faculty became entrepreneurs, taking that kind of a grant. We even approached our alumni for funding those FIRE grants. So a lot of things we did when I was there. We also did similar things for students and all that. And then, for example, this is an interesting number. IIT Delhi filed as many patents in the last 5 years as it did in the previous 55 years. That's a kind of a sudden jump you see in the patent once you fix those kind of problems. And a lot of good things happened even during COVID time, because once you, like I said, all that is required to make academia to be seen as developing technologies is to build a mission mode kind of an approach. Identify the problems, and then people will tend to deliver them. There are good people here, and COVID was such an opportunity. COVID time, basically, everybody was working on only COVID. So within that 2 years, so many technologies people were able to commercialize and take them to the market. I think that's all what is needed for academia to be seen as productive in the sense of translational research. That's all what is required. And this is my last slide. I think India is opportunity. India is lots of problems that we had, but it's also each problem is an opportunity for an academic institution. And R&D in academic institutions is primarily driven by all this, research paper, library kind of a culture. We need to innovate in areas where there is a domestic demand. Local R&D for product development is absolutely essential. If we had done all this research somewhere else, we wouldn't even have owned those patents. We couldn't have commercialized anything, and the cost would not have been as low as what we are able to currently sell them at. And it's possible to do high quality research in academic institutions, so it make it relevant to India's research. And there are, thanks to this government, this is one thing they have done very well. Lot of push for startups now. There are multiple funding schemes. Even the technology innovation hubs, which DST has created, can also fund startups. So there are good things that are happening. And so I say that the creativity in our higher education sector is as important as literacy at the grassroots level. I think when that happens, India will be a prosperous country, and we would have done our job here. I will stop here. Thank you. I'm sorry.
Why I'm asking, I think most of us lost the sense of time during this lecture.
Absolutely.
No, some last week they were sleeping also. It happens.
It was different class than we used to have. Like students are always on their mobile phones. कि एक घंटा सत्र का पूरा हो हम जाए. So it was different class. So it is already I think 5:40. It is 5:36. I think some quick questions can take.
Officially the session is over. You can leave. I mean, those who want to ask questions.
At least, sir, I have a small suggestion. Probably, I think we are very scared to go for patenting, and probably, as you mentioned, we don't have any goal actually to be achieved. So, can you just put us some light how that goal can be set in an institution like ours, and where at least 10% of people can work like that?
Yeah, I think the patenting thing, once you recognize this in the assessments, for example, IIT Delhi, even in BITS, we are doing the same thing. So now in our assessment form, patents also appears alongside the papers and all. So if you, filing patents anybody can do. So granted patents takes minimum, it was completely broken in India. It was taking 10 years or longer. Now it is taking 3 to 4 years. So, but if people are at least filing patents, if we can recognize it in some way, initially at least before the patents are granted and all that, I think that will be one level of enthusiasm. And over a period of time, then these patents will also keep getting granted. And what started as a process, as a cultural change today, after 5 years, you don't have to recognize anybody for just filing patents. Then you can start recognizing people with granted patents. And granted patents, Indian examination system is also pretty good now. They are doing a thorough examination. So US patents are more difficult. But I think if we treat them as equivalent to a paper, many people will come forward. So, and also, we need to ask the tough questions. In IIT Bombay, in IIT Delhi, lot of papers were being written. So once we said you should file patents, right? People started filing patents, but then there were too many patents being filed by some people. And then we asked the question, okay, now you have filed 10 patents, what next? So because again, like I said, the ratio of papers to patents, similarly patents to technology transfers or startups. If I have filed 10 patents, right, and institute has funded all of them, and if nothing is transferred to any industry, no industry is taking any interest in what you are doing, or you are also not trying to start a company out of that or anything, then why are we filing patents? I think once that question is asked, people become more conscious. And at IIT Delhi, Professor Bhim Singh, right? And Bhim Singh, is like thousands of papers. And I told Professor Bhim Singh, I have 4 papers over here. Why don't you now start filing some patents? He said, I can do that, and he started filing, 20, 30 patents every year. I said, Professor Bhim Singh, 4 patents हो रहे हैं अभी, आगे क्या होने वाला है? So now, are you doing something with these patents now? Are you talking to some industry? Are you a student thinking of starting a company? He said, I will do that, Professor Rao, and then now he started a company. So somebody like Professor Bhim Singh, who was essentially publishing so many papers, now he has a startup. He is now looking at technology transfers. I think this is all asking the right questions at at places where we need to ask them. That is all what is needed to change the culture. And once there are more patents, there will be more startups coming out of faculty. Like even if you say 10 lakh rupees for a faculty member to start a company, right? You do a thorough review. And you out of 20 people applying for the 10 lakh grant, you fund only 2 of them. But the message will go that institute is encouraging faculty startups. And in the process, then more and more people will look into that. and then more and more startups will come. Out of tens of startups, even if one becomes successful, even if two become successful, that would still be a great thing. Because the success rates are not so high in these areas, so we need to do it in large volumes and in large numbers. So I think there's enough talent in the academia. We need to leverage that by setting goals and directions. So why students are all only taking IT jobs? This is what I have been writing articles and even my own daughter doesn't. But the problem is, which is the BTech discipline? The core sector, there are no jobs. Why are there no jobs in the core sector? In biotechnology. Even for PhDs in biotechnology, they are paying so little kind of an amount right now. Why is it? Because the research government is encouraging, but when it comes to innovation, they hand it over completely to the private sector. They say that the moment you start a company, we cannot fund it because government money going to a private company, private entity is still a big challenge, right? And then once you start a company as a professor, you also start wondering what has happened to me. I mean, as a professor, everybody wanted to fund me. Now that I am an entrepreneur, nobody wants to give me any money. That is because of the way the government works. So this is something which needs to change. DSP, for example. Every program advisory committee of DSP, I've always been telling them fund ideas, not where the idea comes from. Doesn't matter where the idea is coming from. If the idea is good, if it is a startup coming up with a great idea, we should be able to fund them, right? At least if you say, hey, okay, they will take the money and run away, right? We have no way of controlling them. Make them, associated with an academic institute, but still fund them, right? All this can be done, but unfortunately, they are not doing it. As a result, all this billion-dollar quantum mission, right? What will happen at the end of the day? You would have funded 100 institutions in this country. They would have written 10 papers each. So therefore, every year you will write, 1,000 papers more. But then, where are the jobs because of that billion-dollar investment? There won't be any jobs. And if any of them, even if 20 of them want to start a company, and if we are not able to fund those companies, then there will be no jobs, there will be no growth, and there will be no technology. That is a fundamental flaw right now. That integration of research and innovation is completely, broken right now. There is no seamless integration of research to innovation is what needs to happen. We need more schemes for that. BioLab is one scheme of DBT, right, which does that very effectively for biotechnology. But DST cannot do that. Both are in the same ministry, Ministry of Science and Technology. DBT can do something to fund companies, but DST cannot do that. When I was managing the Nano Mission, I struggled hard. I said Nano Mission should also be able to fund startups. But then the DST guys say that no, we cannot do that. But I said, but DBT is doing that. Okay, maybe they are doing it, but we cannot do that. So the same ministry, two separate departments, one can do, one cannot. So the problem lies in the way we are funding research in this country. Otherwise, to solve that problem, every deep technology area needs to eventually generate jobs. That has to be the motto or motive for any research fund. So you do research, you translate that into company, or you license the technology. There are new product segments which are now, which will require more people, and more people will get hired. Then you will have more students joining those disciplines. So that is currently not happening. So I think it is the way we are managing the research to innovation or the knowledge translation process. So I think I don't blame the students for that, but even students also are in a hurry to earn money. I don't know why they want to earn money. So after BTech, I can tell you 50% of students who come to BITS is a rich enough institute, right? I mean the students who come there are even IITs. I don't think anybody is poor who comes to IIT these days. Why do they need a job after BTech? They don't need a job. But then there is a sort of a peer pressure to take up a job after BTech. Some of them should continue for higher studies. In a biotechnology, you cannot start a company with a BTech degree. You need even a PhD to start a company in nanotechnology, a PhD to start a company in quantum technology. In IIT Delhi, less than 5% of students are going for higher education. Less than 5%. So the 95% of students want a job after BTech. So our top talent, the top students from MNITs and IITs don't pursue higher education, and then the innovation capacity in nanotechnology, in these deep technologies becomes very limited. So with BTech, you cannot start companies in those sectors, and you can only start companies, in IT or with a BTech degree, but you cannot do that in the nanotechnology kind of areas. And these guys have no idea what those technologies are. Everybody wants to create an app, a Adobe app here, a Carpenter app there, and make it $1 billion valuation, and be happy. So I think that is what is missing, and I want to see more and more good students from our great institutions to pursue higher education and explore innovation opportunities in the deep technologies. Until that happens, this problem will continue. There are only jobs in one sector, because all innovation is happening in that sector. That is where the jobs are. So I think that's where the country is currently.
So, thank you, Professor Rao, for such an enlightening and wonderful lecture. I'm sure the audience are greatly benefited by the insights on the topic. I now request Director Sir to please present a memento to Professor Rao. Making this lecture a success. First, I would like to thank Professor Rao for sparing valuable time from his busy schedule for such an enlightening lecture. Actually, this lecture was scheduled earlier on 22nd of November, but because of busyness of Professor Rao, it had to be extended, postponed to this date. We are thankful to Professor Padi for extending moral, administrative and financial support. And when it comes to the audience, I was very apprehensive about having enough audience for this lecture. So I tried my best. और मैंने सबसे यही कहा था कि this lecture will be different. So I think this has come to, this is what I told you. You must have felt that.
Yes.
So that is one thing. Sincere thanks are due to the faculty, students, and other for their presence in the lecture and my patient listening. Student volunteers are key to organizing such an activity in an educational institution, and today's lecture is no exception to this. I would like to thank specifically Jitesh Sharma and Shashwat Jain, both the students, PhD and MTech, who have worked hard to make this event a success. Thank you all again, and Jai.